again, students. This is Math Man. And when I'm not being a math superhero, I love watching my other superheroes. Like Superman, one of my favorites. The cool thing about superheroes is they have powers. And so do numbers. So let's find out about them. They're called exponents. So, let's go to the board.
Alright students, now that we're at the board, let's look into properties of exponents, including addition, subtraction, multiplication, division of exponents, also zero exponents, and powers raised to a power. First, we'll talk about what a base is. A base is a number or expression, integer or variable, that can be raised to a power, or an exponent. For example, if we have a base, which is x, and it's raised to the second power, x would be the base, and 2 would be the exponent. Exponents. A quantity representing the power to which a given number or expression is to be raised or multiplied by itself. For example, if we have 9 as the base, and 2 as the exponent, that would mean 9 times 9. So, 9 to the second power would be 81. The combination of a base and the exponent can be referred to as an expression. Now let's look at addition and subtraction of exponents. In this case, we'd have to have the same base and the same exponent. So if you add or subtract two numbers or expressions with the same base and the same exponent, you can add them, but only add the bases and leave the exponents alone. So, in these two examples, we have x to the third power plus x to the third power. So we'll leave those exponents alone and just add the bases. This would be 1x to the third plus 1x to the third, so 1 plus 1 would be 2x to the third. In subtraction, we're going to subtract the bases. So we have 2x squared minus 1x squared. We're going to leave the exponents alone and just leave it as x squared. Next, we'll look at multiplying bases with exponents. In this case, we can have the same base, and we should have the same base. And you can have any exponent. They don't have to be the same. So if you multiply two expressions that have the same base, you add the exponents together, but you leave the bases alone. So, for example, if you have b to the third power times b to the third power, we're going to leave those bases alone and just add the exponents. So it would look like this. b to the third plus 3. 3 plus 3 is 6, so our answer is b to the sixth power. In this scenario, you have y to the fifth power times y to the second power, or y squared. Since we're going to add the exponents, we would have y to the 5 plus 2 power, or y to the seventh. Alright, so now we're going to do dividing. Again, you'd have to have the same base, but again, any exponent. If you divide two expressions that have the same base, subtract the exponents and leave the base alone. So again, for examples, if I have x to the fifth power divided by x to the third power, we would subtract those two. 5 minus 3 would be 2, so our answer is x to the 5 minus 3, or x to the second power, or x squared. In this example, we have z to the 10th power divided by z to the 7th power. So again, we have z to the 10 minus 7th power, which equals z to the third power. Now I'm going to show you some exponents with special cases. First, we're going to talk about an exponent of 0. Now this is not quite what you would think. Most people think about 0 and you think about multiplication and things like that, and you would think, okay, well anything times 0 is 0, right? Well, in this case, we're saying that the base is multiplied by itself 0 times. So it's not saying the base multiplied by 0, but it's by itself 0 times. And in this case, anything raised to a power of 0 is going to be 1. So no matter what the number is, if you have any base raised to the power of 0, it equals 1. So for example, 5 to the power of 0 equals 1. 90 to the power of 0 equals 1. 777 to the power of 0 equals 1. 198,765 to the power of 0 equals 1. It can be a variable. X to the 0 equals 1. Or it can be anything, literally like Mathman to the 0 power also equals 1. Okay, now we're going to talk about negative exponents. In this case, we're going to talk about raising a base up to a negative exponent. So I'm sure you're saying, well, Mathman, how can we raise something to a negative power? That means it would have to be multiplied by itself a negative number of times. And I know that sounds ridiculous, and it's because it is. So what we're going to do to make more sense of it is we're going to look at this example. X to the negative 2 power equals 1 over x squared. So to explain this and understand it, I want you to imagine for a moment that x raised to the negative 2 power is over 1. Just like any integer, you can take that whole number and put it over 1 in a fraction, and it's the same number because anything divided by 1 is just the same. So if we had it that way, with x to the negative 2 power over 1, and then we invert it or flip it, we'd have 1 over the positive exponent. So if you have a negative exponent, this is the inverse of a positive exponent. This tells how many times to divide by the base. In this case, you have to flip the expression. So here's some examples. X to the negative 3 would equal 1 over x to the third. C to the negative 5 would be 1 over c to the 5th power. 8 to the negative 2 power would be 1 over 8 squared, which would be 1/64. All right, the next case we're going to look at is raising a power to a power. So in this case, we would take a whole expression, something like x squared, and raise the whole expression, including the exponent, to another power. So for this example, we're going to look at x squared, the whole expression raised to the 4th power, which means you'd have to have x squared times x squared times x squared times x squared 4 times. So what we're going to do in this case is we're going to multiply the exponents. So we have x to the 2 times 4 power, which would be x to the 8th power. So if you have an expression with an exponent that is also raised to another exponent, you multiply those exponents. So here's some examples. X to the 3rd power raised to the 2nd power. So it'd be x to the 3 times 2, or x to the 6th power. C to the 5th power raised to the 2nd power would be 5 times 2, so we have c to the 10th power. And 8 to the negative 2 power times negative 3, negative 2 times negative 3, same sign as positive, 8 to the 6th power. Now, it's question time! It's time to simplify the expression, students. Let's see what we can do. P to the 6th plus p to the 6th. Since we're adding these bases with exponents, we're going to have to add the bases and leave the exponents alone. So we have 2p to the 6th. Next, we have y to the 3rd power times y to the 6th power. So since we're multiplying, we have to add the exponents. We'll leave the base alone. So y to the 3 plus 6 would be y to the 9th power. Y to the 3rd raised to the 7th power. So again, when we raise a power to a power, we're going to multiply the exponents. So we're going to leave the base alone. That's going to be y to the 3 times 7 power, which would be y to the 21st power. Next, we have x to the 8th power over x to the 5th power. So when we divide, we subtract the exponents. So x to the 8 minus 5 power would be x to the 3rd power. And finally, we have h to the negative 5. Now remember, when we have negative exponents, we're going to use the inverse property, and we're going to put it under a fraction under 1. So 1 over h to the 5th. All right, students, this time let's have you work on it on your own, and I'll give you some music to work to. So again, try simplifying these on your own.
students, now that we learned a little bit about exponents, hopefully that'll help you out so you can get through those math problems, those difficult ones you have a hard time and you struggle with them. So, if this was helpful though, hit that like button, hit that subscribe button, and hit that bell so you can get a new update every time MathMan posts a video. So I'm going to leave you today with a joke. How do you make a number into a hero? You give it a power. So until next time, MathMan, out.